what I'm going to speak about today is part of a bigger project. It's a book project in which I want to revive logical empiricism, which does not mean, so don't worry too much. Yeah, it doesn't mean that I'm going to revive all of it or buy into all of it. Of course, they made various mistakes that need correction. I'm not going to reject metaphysics and all of that, but it's still, if things work well, something that's close enough to a, let's say, Carnapian version of logical empiricism, a logical empiricism that was advocated by Rudolf Carnap, one of the main proponents of logical empiricism back then. And part of it is a sub-project on merely expressive devices, which will be my focus today. So that you won't hear that much about the bigger project, and let's keep it between us, okay? Because people might think I'm crazy. So unofficially, you know what it's really about, but officially it's just this tiny thing on merely expressive devices, and that's all. Especially, don't tell Tim about my bigger project because he might not like it. Okay. Oh, hi Tim. Yeah. All right. Let me share my slides. So I hope you can see them fine. Merely expressive devices. What do I mean by that? So these are linguistic items, something in language. And by a merely expressive device, I mean a linguistic part of a sentence, say A, such that that part plays a role in determining the proposition that is expressed by that sentence A. Think of propositions as sets of possible worlds. So the linguistic part that I will call a merely expressive device, it will play a role in determining the set of possible worlds that will be expressed by a sentence in which that merely expressive device occurs syntactically. But that will be it. There's nothing over and above that a merely expressive device will do. In particular, it will not play any role whatsoever in determining the truth condition of the proposition it helped to express. Okay, so once it has helped us to determine the proposition that is expressed by a sentence, its job is done. Whether that proposition then is true or not, the truth conditions of the proposition, the merely expressive device has nothing any longer to do with that. Okay. Now you might think at this point, are there merely expressive devices? Is there a point in driving a wedge between a proposition and the truth conditions of a proposition? For the time being, and that will later also be my first example, think of logical operators. For example, think of the disjunction symbol, right? The or symbol. I want to say that's a typical case, a paradigm case of a merely expressive device. So you can use the disjunction symbol to help yourself to express a proposition. Think of a sentence that you formulate. The sentence includes a disjunction symbol, and you express thereby a proposition. You grasp a thought, as it were. But once you have determined that proposition, the disjunction symbol has nothing to do anymore with the truth conditions of the proposition thereby expressed. In particular, it doesn't represent anything in the world. It's not that in order to determine whether that proposition is true or false, you would need to search for anything in the world that corresponds to the disjunction symbol. There is no disjunction symbol entity waiting out there in the world for you to be discovered. So I don't think that's a new thought, not at all. In fact, I think of the idea that logical operators are merely expressive devices as something like the traditional account of logical symbols. A paradigm case instance where you find that stated in very similar terms is Wittgenstein in the Tractatus, where he says that his Grundgedanke, his basic thought is that the logischen Konstanten nicht vertreten, that the logical constants do not represent. And that's very roughly what I have in mind too when I call the logical symbols merely expressive devices. What I will do in the talk now is I want to rationally reconstruct such devices, so make what I just said a bit more precise, a bit more systematic, and then apply what we get thereby. And the main way of doing that will be, I will introduce what I call conceptual frameworks. So those will be my tools by which I will make this talk about merely expressive devices clearer and more precise and more systematic, I hope. These conceptual frameworks basically consist of two parts. There will be a purely mathematical part, so that's represented by this square here. And then there will be a component which I will call a label, so something in the world about which we want to reason or talk in that conceptual framework. And if you take these two components together, the purely mathematical structural component and the worldly component, you bunch them together, you get what I call a conceptual framework. Now, if you start with a sentence like this one here, A, then what the sentence will do ultimately is determine a set of entities in the purely mathematical part of the framework. And these entities I will call possible worlds. So A will determine an intention, right? A set of possible worlds, as we have it in regular intentional semantics. But don't think of these worlds here as anything metaphysical. So in my case, in my conceptual framework, they will be purely mathematical structures, purely mathematical entities. And then once we have a proposition like that, a set of purely mathematical worlds, we can compare the members of that set, these worlds, with, as it were, reality, the reality that we want to talk about. That's this labeling here. And if the comparison works out fine, roughly if there is an isomorphism, a bijective structure preserving map from one of these worlds to the label, we will call that world actual and we will call the corresponding proposition true. So in this way, we will get truth conditions of propositions. And now my merely expressive devices, like the disjunction symbol, they can occur in a sentence like that, in this A, and they play a role in that arrow here for that determination. They help us to determine that proposition. But then, as I said before, that job will be done when we compare the proposition, as it were, with reality. The disjunction symbol or anything related to the disjunction symbol will not have any role whatsoever to play anymore. That's why the or symbol will be a merely expressive device, right? And then there will be other linguistic items that are not merely expressive devices. They will also have a role in determining propositions, but then they will also finally have a role in determining whether the corresponding propositions are true or false. They have a second role to play. Since the merely expressive devices don't have the second role to play, they are merely expressive devices. They merely have the job of expressing propositions or helping us to grasp thoughts. That's the idea. Now, this terminology of labels that comes from a comparison with graphs, right? You have nodes, you have edges, and then people like to talk in the following way. They say there are unlabeled graphs, they are purely structural, purely mathematical. That's, as it were, this mathematical part here. And then sometimes we label the nodes or the edges of a graph. Maybe the nodes stand for people and the edges stand for an acquaintance relation between people. Then we get what's called the labeled graph. Okay, the labeled graph is a graph with, say, empirical entities that label the objects in the graph structure. Then you get a labeled graph. And my conceptual frameworks are like that. They have this purely mathematical part, that's the unlabeled graph, and then you have a labeling. Typically, we label these mathematical entities, things, parts of these mathematical structures with empirical entities, but anything really, in principle, could be a label. But it's good to think of it in the way that we label it with people and other things in the physical world or in the mind and something like that. So those will be my conceptual frameworks, and they will be my main tool of making this talk of merely expressive devices more precise. I will work out the details of such an intentional conceptual frame semantics for these merely expressive devices. And once we have it, I will draw some philosophical conclusions from it. I will not give you an explicit definition of conceptual frameworks, although this could be done for a fairly general class. What I will rather do in my talk is I'll give you 3 examples, but I hope they are sort of sufficiently paradigmatic or prototypical that you can see how to extend the same idea to other application cases that you might be interested in. And in fact, in my book project, I'm going through various other applications. So I hope ultimately you will believe me that this endeavor is a fruitful one if things go well. So my methodology is a bit like, say, Tarski on truth. He doesn't define truth for variable L, but he shows us how to define truth for very interesting, sufficiently paradigmatic object languages. And then in that way, you can see how to extend the same approach to other application cases, other languages for which you might want to define truth. And you can do it in a similar way. And the same methodology I apply here. And my 3 examples of merely expressive devices will be, as promised, the logical constants. Then I will argue that stipulatively defined terms are merely expressive devices too. And finally, and that's the more controversial part, I will argue that linguistic items in metaphysics, like the metaphysical necessity operator, can be viewed as a merely expressive device as well, right? And once we are there, I hope you can see that you can extend the approach to various other symbols, okay? But of course, not every symbol will be a merely expressive device, and that's not a problem for my approach. I'm not claiming otherwise. Ultimately, I want to show in that way that some of the tenets of Carnapian logical empiricism can be vindicated, at least to the extent to which they were dealing with merely expressive devices, and I don't have any ambition beyond that in the talk today. Okay, let's build some conceptual framework, shall we? So, as I said before, we first need a mathematical part, a mathematical structure of purely mathematical possible worlds. So let me do that here in a very simple way. Let's say our set of worlds, that's this capital W here, is a set of triples, mathematical structures that look like this. Okay, so these will be my worlds, where the first component, the D, is a set of natural numbers, finite, non-empty. M1 is a subset of D and M2 is a subset of D. Run through all the combinatorial possibilities satisfying these constraints, then you have all the possible worlds in the first framework that I'm currently building. Okay, so not much has happened. This is pure math, right? Nothing has happened really. So for example, one of these D sets could be the set of natural numbers from 1 to 7. And then M1 would be a subset, say the set 1 to 3, and M2 would be a subset, say the set from 3 to 5. And you take them together as a triple, that's one of my possible worlds. Okay. There's not much built into these worlds, except that D, which will be something like the domain of the world, as you will see shortly, is finite. So I hope you don't worry too much about that at this point, and non-empty. Okay, and non-emptiness is sort of really a presupposition, as it were, of classical logic, and then shows up in that way. Domains in the standard semantics for classical logic are assumed to be non-empty, and I make the same presupposition here. And once we have this set of possible worlds, pure math, we now add a label structure, and when we put them together, we will have the first conceptual framework. And in this case, the labeling consists again of 3 entities, namely the set of humans, the set of men, and the set of married people at some point of time, which we keep fixed. Okay, so fix a point in time, you get a set of humans, a set of men, a set of married people, you put them together because in this framework, you want to think and talk about them. And then you have the label, and then if you put together the set of possible worlds and the label structure, you get my first conceptual framework. That's this F. Okay, so you can already see my conceptual framework will later on be to do with men and being married, or let's say unmarried. So you can see where I'm going with that. Okay, so there are certain examples in philosophy that by law you're obliged to take up and analyze, and you can guess at this point what kind of example I will use later. Okay. So this explains my idiosyncratic choice here. Okay, that's my conceptual framework. Now the next step is I want to define worlds in this framework to be actual. Okay, and as I said before, a world will be actual in the framework just in case the world, a purely mathematical structure, gets the structure of the labeling right. There is an isomorphism between the world and the labeling. In this case, that is a function, L for labeling, between D, the domain of the world, and the set of humans, that's sort of the set of entities that I want to reason or talk about, that is structure preserving in the sense that the labeling is bijective, and the M1 set in the world corresponds structurally to the set of men in the label structure, and the M2 set in the world corresponds structurally to the set of married people in the label structure. And the correspondence, that's this if and only if claims here, okay? So a number is in M1 here, just in case its label, that's a human being, is a member of the set of men. It's a man, not a woman, okay? Now, in this case, as we will see, there is in general more than one world that's actual, but all of the actual worlds are pairwise isomorphic. So up to structure, I don't care whether there is more than one actual world. Okay, but other than that, think of it just as ordinary intentional semantics. In intentional models, we also like to fix a world that is the actual world, and the other ones are the merely possible ones. And something like that will be possible here as well. Now, propositions, as in intentional semantics, will be sets of worlds. In this case, a subset of the set capital W of all worlds. The only little bit of finesse here is really, in my general approach, a proposition will be a set of possible worlds that is closed under isomorphisms. A proposition is not any old set of possible worlds, but a set of worlds closed under isomorphisms. Okay, and again, that's not a new idea. You find the same idea in measurement theory, right? People there have a similar approach. They have something purely mathematical, right? When we measure, this involves numbers and the like. Okay, then there's something that we want to measure. That's some empirical stuff out there, and then we study by measurements some structure preserving map between them. And then they also have notions like, a statement is empirically significant and so on. And when making these notions precise, they have the same idea to look at propositions that are invariant under isomorphisms. But other than that, you can just plug in this idea that, propositions are sets of possible worlds. And then I call a proposition true in the framework if it includes a world that is actual in the framework. Okay, so that's again Noel's idea, proposition. What is a true proposition? One that includes an actual world. Okay, and again, there's something very close to that if you think of the non-statement view of scientific theories in general philosophy of science. Their theories are also viewed as sort of sets of models. Okay, and then people advocating the non-statement view would define notions like truth or empirical adequacy or the like by the existence of certain structure preserving maps between these models, pure math, and the phenomena out there. And I use the same idea here for my conceptual frameworks. Okay. Now I say true in the framework and actual in the framework because all these notions are relativized to the framework, right? So for other frameworks, we get maybe a corresponding notion of actuality, but then it will be actual in the framework F prime rather than in F. Now, for instance, let's fix a point of time where things are sufficiently simple, sort of the beginning of all time. Okay, so this is not a historical example, as you will see. It's not even faithful to the text, as you will also see shortly. But give me that. It makes things simple. So we're at the beginning of all time. The set of humans is the set consisting of Adam and Eve. The set of men, that's just Adam, and the set of married people. So here I'm not faithful to the text, okay? Let's assume Adam and Eve were married, okay? So Adam is a married person and Eve is a married person. Married is something unary here. So it's not blah, blah is married to blah, blah, but you're a married person or not, okay? And both are married, give me that. Then this would be an actual world, okay? It gets sort of the domain right, the cardinality of the domain as it were. And think of it in the way that 1 is mapped to Adam and 2 is mapped to Eve, okay? Then the single set of 1 gets this set of men right, and the set 1, 2 gets the set of married people right. So there is a bijective structure preserving map between that world and our labeling structure, hence that world is actual. But W2 is actual as well. It's isomorphic to W1. It's just that the 2 now plays the role of Adam and the 1 plays the role of Eve. Okay, but other than that, it's an actual world. On the other hand, these worlds here, W3 and W4, they are not actual. Okay. So here there would be only one person that is married, and it's the man, as it were. But this forgets about Eve because she's also married. So this world and also the isomorphic W4, these worlds don't get the structure of the labeling right. Okay, so they are not actual worlds. And for that reason, the set W1, W2 is a true proposition, but the set W3, W4 is not a true proposition. W3, W4 does not include an actual world. W1, W2 does. Okay. If you look at the set of all worlds in which you run through all the possibilities, it's just that sort of what represents the set of men, the second component, the X here, is non-empty, then that's another true proposition. Why? Because it includes, for example, W1, right? So this is a non-empty set. W1 is a member of that proposition. W1 is actual, so that proposition is true. And if you take the set of all worlds, capital W, of all worlds whatsoever in the framework, then accordingly, this is also a true proposition. And now here's the thing. I want to say that the framework does not constrain the label structure in any way, with the slight exception that I assume D to be finite and non-empty. Okay, so if you worry about finiteness, let's talk about it later. Usually in these contexts, you don't worry about that. Okay, so let's disregard the possibility that there are infinitely many people around in the world. Okay, but other than that, I run through all the possibilities, right? Maybe there are 7 people, maybe there are 10,000, maybe there's just one. Okay, and non-emptiness I already explained. And then I run through all the combinatorial possibilities of what counts as a man there and what counts as merit. So I run through all the combinatorial possibilities in my conceptual framework. And therefore, whatever the labeling structure is like, whatever the phenomena out there are like, I must get the structure right, because I made sure that in my conceptual framework, in its purely mathematical part, I've run through all the mathematical possibilities there are anyway. Okay? So therefore, by math alone, and of course, how I define the framework, capital W is true in the framework. There must be an actual world in capital W. Okay? So in contrast, the truth of this set here, W1, W2, that's due to the framework and the facts, as it were, right? Because that set just includes 2 possible worlds and do not run through all the possibilities, okay? So that I get here a true proposition, that's also to do with what the labeling structure is like, okay? That's in contrast with capital W. Whatever labeling structure I might have chosen, capital W would have turned out as being true, okay? Now, final part, we add language. So far, this was all pure logical thought, as it were, okay, in the Fregean senses. But now we add a first-order language, say, and you get the idea. So we have quantifiers. The quantifiers at a world will range over the domain of the world, that's capital W. And then in the language, say, we have 2 unary predicates, the predicate man and the predicate merit. And at a world, we interpret man by the M1 component, right, the second component of the world. And we interpret the unary predicate merit by M2, the third component of a world. And then we can define for all the sentences in the first order language in the usual way, under which conditions a sentence is true at a world in the framework, right? And here you plug in the standard semantic rules. So you use the little w, the world, as a model, and you have the standard semantic rules, okay? So not A will be true at the world, just in case A is not true at the world, and so on. And at the atomic level, you make use of the interpretation that I've just described. And then you say, again, in a standard intentional sense, a sentence expresses a proposition, okay, if the proposition consists of all the worlds at which the sentence is true. And finally, you call a sentence true in the framework, not true at a world in a framework, but just true simpliciter in a framework, just in case the proposition it expresses is true in the framework. And truth for propositions, I have already explained on the previous slide. Okay, so here I side with the somewhat older tradition that would think primarily of propositions as the bearers of truth values, and which then defines truth for sentences by the propositions that the sentences express. Okay, a true sentence is one that expresses a true proposition. That's the strategy that I use here. So this is different from Tarski, who defined famously truth directly for sentences. Okay, I'm not doing that here. So for example, there is an X such that X a man is true simpliciter in the framework. Okay, you just look at the set of worlds that is expressed by it. This is the set that I had on the previous slide, and we have already seen that includes one actual world, and hence it's a true proposition. Accordingly, the sentence that expresses that true proposition must be true. Okay, the proposition that is expressed by it is distinct from the set of all possible worlds in the framework, because it rules out certain worlds, right? It rules out those worlds where the M1 component is empty, yeah, where there are no men, as it were, at that world. If you take the excluded middle, there is a man or there isn't a man, then that's true at every world in the framework. Okay, it's a logical truth, no big surprise. And accordingly, the proposition that is expressed by it is the set of all possible worlds in the framework. Okay, so far, I think all of that should be very familiar from intentional semantics. The only little thing that happened is this clear separation of a two-layered structure. One is mathematical, and the other one is, as it were, here empirical. And then you put them together, okay, and let them do their job. So for example, in the framework, as you've seen, the M1 component of a world is meant to represent the set of men. That's the label that it has. Why do I know that the M1 component has man as its label? Because that was showing up in the truth condition, in the definition of actuality. Okay, there we compared the M1 component with the set of men. Yeah. that figured in the truth condition ultimately for propositions. So if one now introduce the notion of a concept as in intentional semantics, like a function from possible worlds to extensions, one might say that in the framework, the concept of being a man is meant to represent the set of men, its label, which figures in the truth conditions for propositions. And once you add the language, as we've just done, you might also say in the framework, the predicate man expresses the concept of being a man, an intention, which represents the set of men, its label, which figures in the truth condition for propositions. And that is, in the framework, the predicate man does two things simultaneously. One, it contributes to the expression of propositions, okay? And secondly, via the concept it expresses, it contributes to the truth conditions for the propositions thereby expressed. And that is why I want to call the predicate X is a man, the predicate man, not a merely expressive device. It is not a merely expressive device, okay? It has an expressing job to do, that's the first one. But additionally, it also contributes to truth conditions of propositions. And that's why it's not a merely expressive device. It does more than expressing propositions. Now contrast that with the logical operator. Say again the disjunction symbol, right? We had a first order language, so we had all the standard logical symbols in there, including the disjunction symbol. Now, there was no coordinate in our possible worlds for disjunction. Yeah, it's neither D nor M1 nor M2. Okay, in the truth condition for propositions, or in the definition of actuality, there was nothing that related to the disjunction symbol in any way. So you can again introduce the notion of a logical concept as in intentional semantics. You might say in the framework, the concept of disjunction is there, that's fine. It does not represent anything, any label that would figure in the truth condition for propositions in that framework. With the language added, if you look at the symbol now, the disjunction symbol, then the logical operator or expresses the concept of disjunction, which does not represent anything, any label that would figure in the truth condition for propositions. So that is, the operator or in the framework does one thing, it contributes to the expression of propositions. Think of the excluded middle. There we had a rule that helped us to determine the proposition that was expressed by there is a man or there isn't one, okay? And there the disjunction symbol had a role to play. It helped us to determine that proposition, but it doesn't have a second role to play. Once that proposition has been determined, the disjunction symbol or the concept disjunction, yeah, doesn't contribute any more to the truth condition for the proposition thereby determined. That is why I want to call the disjunction symbol a merely expressive device. It merely has job one, but doesn't have job two. That's the contrast with the predicate man that I had before. Okay, so of course, the proposition expressed by A or B is, for example, the union of the propositions expressed by the disjuncts, but it's not the case that the union here, the union function or the truth function for the or so, would be compared to any label in definitions of actuality or truth in the framework. And that is why the disjunction symbol is merely expressive. Okay, you could also say it's merely structural. Okay, but it's not important that it's a structure of something in the world. It's just important that it helps us to determine this set of possible worlds, which are purely mathematical entities, and that's it. So the upshot is, in this framework, I want to say that logical concepts do not represent, and the logical operators are merely expressive devices. So you could say that the disjunction symbol expresses a concept, but it does not represent the property out there in the world, as it were. Okay, so there's a difference here between the concept and the property. And now you might say, yeah, sure, Hannes, you've built this weird framework. Sure, you can make anything happen, but why should that be interesting? That's really odd, okay? But I want to say this is not an odd feature of the framework, but rather, I hope, a sufficiently good model theoretic reconstructions of how logical operators work semantically in natural language, or at least in certain fragments of natural language, and in many of the formal languages that we're interested in. The tradition would have said something like that, something in that ballpark, by saying logical constants are syncategorematic. Okay, the predicate man is not, but the logical or is. Okay, and that's something close to what I have in mind here. That's an old idea, and I have now rationally reconstructed idea in my little framework. So that's my first example. Now let me turn to my second example. And here I will make it very easy for you and also for me, to be honest. Basically, I'll add a little thing, and in this way, I will move to the previous framework F and end up with a new framework F prime. And the little additions that I make, I've put into red. So you can see immediately what's going to change. So again, we need our purely mathematical worlds. I call that W prime here now. And those are our old triples, D, M1, M2, but I add one component. Every world also now has a fourth component, a B set. Okay, it's another subset of D. But again, the members of D are the natural numbers, and M1 and M2 a subset of D, and so on. So B is the only thing that I add that's new. That's why it's in red. But now there comes a little change. I still run through all the combinatorial possibilities with respect to D and M1 and M2. But as far as B is concerned, as it were, I compute the set B from the set D and the set M2 and the set M1 by this little rule, okay, which is sort of part of my definition of what that framework F prime is that I'm currently presenting to you. And you can see at each world, B is the intersection of two sets, namely D minus or D without M2. So those are the numbers that are in D, but not in M2. So it's something like not M2. And the intersection with M1, okay? So remember, M2 was something like, married. So if I take this complement here, this will be something like unmarried. And M1 was to represent men. So, again, you get the idea what I'm aiming at, okay? And now I add my labeling structure, label prime. So again, I have the set of humans, the set of men, the set of married people. And now I have this funny asterisk here. And this is just a little signal, a mnemotechnical device that tells us, no, I'm not going to label the B component. So this will mean when identifying actuality and truth, I will not compare the B component to the label out there, to the world out there. I will still only compare the D, the M1 and the M2 components. Those are the components for which I still run through all the combinatorial possibilities. Okay? You will see very soon why I do that. Okay. Now, if you take together the set of worlds that I've just explained and the new slightly by this asterisk extended labeling structure, you put them together, you get the new framework. That's F prime. That's my second example framework. And then you define actuality again, and nothing changes. And in fact, really nothing changes because, as I just said, as announced, I don't have a fourth clause here in which I want to say that the B component gets the structure of, anything right that's in the label structure. It doesn't figure at all in my definition of actuality. Then I introduce the previous definitions of truth for propositions and so on. And again, accordingly, that B component will not play any role whatsoever in the truth condition for propositions. For that reason, again, the framework does not constrain the labeling structure at all, because I still run through all the combinatorial possibilities with respect to those parts of my worlds that I actually compare to the real world, as it were, to what I want to think or talk about, namely the labeling structure. Therefore, by the same reason as before, by math alone and how I define the framework, there must be an actual world in F prime. Okay. Now, if I had labeled B by something in the real world, okay, and then I would have added another clause here, the B component would also have to get something right. Okay, and since the B component was determined by D and M1 and M2, basically I would constrain the labeling structure in the way that whatever B is compared to would have to relate in the right way to the set of humans and the set of men and the set of married people. Okay, and that might fail for some worlds and not fail for other worlds. Okay, so it could be that if I had labeled the B component here, I wouldn't have run through all the combinatorial possibilities. In fact, here I would not have, okay? And hence I couldn't say by math alone and how I defined the framework, there must be an actual world, okay? So then I wouldn't speak of a framework anymore. Rather, what I would have defined is something like a theory, okay? A theory, let's say what it is, a theory of bachelors, okay? Theory of bachelors and humans and so on, okay? And that theory might fail or might not, there is no guarantee. By math alone and by the way I set up the theory, there would be no guarantee that there is an actual world, that theory is true. But that's not what I did here. B is not labeled, okay? And that's why this is still a conceptual framework. It's not a scientific theory, as it were, about bachelors, okay? Now I add language again. I use my previous first order language, but I add one unary predicate. The predicate acts as a bachelor. I reformulate all the previous definitions for sentences, so truth at the world, sentence expressing a proposition, truth for sentences is still explained by truth of the proposition expressed by a sentence, and so on. Then you get, as before, the sentence "there is a man" is true in the framework, true simpliciter, in the Adam and Eve labeling structure, and everything that we had before remains the same. But now we get additional sentences with the bachelor predicate. For example, you expected it. For all X, X is a bachelor just in case. X is an unmarried man. X is not married and X is a man. And that sentence in my new framework is now also expressing the set of all worlds over the new framework F prime. Okay? Basically, bachelor, at a world, the extension of bachelor at a world is given by the B component. And the B component relates to the other components just as expressed linguistically by that object language sentence. Okay? And since the set of all worlds in the framework was true by math alone and the way I set up the framework, the corresponding sentence is true in the framework by math alone and the definition of the framework. Okay? Now, if we introduce the notion of a concept again as intentional semantics, we can say in that new framework, the concept of being a bachelor doesn't represent anything that would figure in the truth conditions for propositions. The reason is I don't compare the B component with anything in the labeling structure. With the predicate bachelor being added, you might say that the predicate X is a bachelor expresses the concept of being a bachelor, which does not represent anything, any label that would figure in the truth condition for propositions. That is, in F prime, the predicate bachelor does one thing. It contributes to the expression of propositions, but it does not do the other thing. It does not contribute to the truth conditions of propositions thereby expressed. Okay? In other words, I want to say that the predicate bachelor is a merely expressive device in that framework F prime. Okay? It does hold that the proposition by, for example, expressed by "there is a bachelor," right? That proposition is that proposition, the proposition expressed by "there is an X," such that X is an unmarried man. Okay? That's the case. But that doesn't mean that you would have to compare the B component of a world with anything in the labeling structure when determining whether such a proposition is true or not. The only thing that you compare is sort of the M1 and the M2 components. Okay, the things that were corresponding to the predicate man and married. Okay, and the quantifiers that were ranging over D, and these things, those are the things that mattered. Okay, but not the predicate bachelor or the concept of being a bachelor. It didn't contribute to the proposition thereby expressed here, to that square brackets here. So the upshot is that defined concept of being a bachelor doesn't represent, and the predicate bachelor is a merely expressive device. You could say it expresses a concept, but it doesn't represent the property out there. And now you might think, yeah, Hannes, again, this weird framework, sure, I believe that, but why should I care? But I would say that what I've just done is I try to rationally reconstruct how stipulative definitions work semantically or model theoretically, if you like. Okay? Because what's literally happening in F prime is, as it were, the predicate bachelor is being defined, stipulatively introduced, explicitly defined in terms of, unmarried man. So that's why when you then determine propositions expressed by sentences that include that predicate, really what's happening is you look at propositions that are expressed by, and then you have a sentence really that involves, unmarried and man and quantifiers and the like. Okay, and then you can check those propositions whether they are true or false, include an actual world or not. And that involves, comparing the components at the world with the labeling structure. But there, the predicate bachelor or the concept of being bachelor doesn't have any role whatsoever anymore. Okay, the meaning of the bachelor predicate is given by the meanings of married and man. And since that is so, the predicate bachelor does not itself contribute to the truth conditions of the relevant propositions that are expressed by such sentences that involve the predicate bachelor. The primitives, married and man, they do. They are not merely expressive devices. Okay, and now it becomes handy to introduce the standard classical definition. Okay, you define a sentence to be analytic in a framework like that, just in case the set of possible worlds expressed by the sentence in the framework is the set of all worlds whatsoever in the framework. Here, capital W prime. Okay, and hence you get, for example, that all logical truths are analytic, as is the statement, for example, here I just have the implication for all X, if X is a bachelor, then X is an unmarried man. Okay. Now, what's important here is that we really run through all the combinatorial possibilities with respect to the mathematical components that figure in the truth conditions ultimately for propositions. Okay, and since we've done that, okay, again, this is a framework, not a theory, and what we get is an I think, natural notion of analyticity here. Okay, so that's very roughly how the definition, how the tradition would have said, if a sentence follows logically, say, from definitions, okay, and logical truths, then let's call that analytic. Something like that is going on here, but it's the model theoretic counterpart of it. Okay, now that's for bachelor. Really, ultimately, we do not care so much about bachelors. But say, here's another application. Say you're a disputationalist about truth. Okay, so then you might think that the truth predicate is just a handy device that helps you to express certain propositions. Okay, maybe you couldn't express them otherwise. Maybe it's just, you know, a quick and useful and handy way of expressing propositions, and that's all that the truth predicate does. Okay, it does not represent a property out there in the world. You know, these are sort of phrases that the disputationists like to say. You might have wondered what they really have in mind here, but now you can actually build a framework by which you make that more precise. Okay. The way to do it would be you add a predicate TR, okay, unary predicate to your object language. You need the usual devices, you need names for sentences, a little bit of syntax, you know, the usual stuff. All of that could be done mathematically, Gödel numbering as it were, okay? And then at each possible world, again, which is a purely mathematical structure, you would have an extension of the truth predicate, okay? And then you would have all the definitions that I had, okay? But you would not compare the extension of the truth predicate at a world with anything in the labeling structure. Okay. Rather, the truth predicate would only have a function in helping you determine propositions. But when you then determine the truth conditions for these propositions, the truth predicate or the concept of truth doesn't have to play any role anymore. Okay. You never compare the extension of the truth predicate with anything out there in the labeling structure. In the resulting framework, the predicate TR would only help us to express propositions, but it would not represent properties out there. In other words, TR would be a merely expressive device. It's the same idea. And in this way, you can make more precise, I think, what the disputationalists about truth think is right. Now, if you're not a disputationalist, that's also fine, okay? You would then say, no, actually, I label my extension of the truth predicate of the world, okay? And that's also fine. Then you're not a disputationalist, and, you know, certain things will change. For the disputationalists, the instances of the Tarskian truth scheme, they will become analytic, okay? If you do it otherwise, you label the component of the world that corresponds to the truth predicate, okay? If you do it that way, you're not a disputationalist, and the instances of the Tarskian truth scheme will end up not being analytic in the framework that you've built, okay? And both of them are fine, and then it's a question, what's more useful for certain applications, okay? That's the idea. Now, I have another example, and that's it, my third example, okay? Now it gets more controversial, okay? So far I thought, yeah, stipulatively defined terms, they're sort of merely expressive devices, I get what you have in mind, disputationalism, okay. Let's talk about metaphysical expressions, okay? So that will be my last example. So I built another framework. This time I have to switch things around a bit, okay? But I presuppose analogous definitions of actuality and truth and so on. I won't repeat them anymore. You got the idea. Now, the mathematical structure, I will make much simpler now, okay? I will fix that to be the set 1, 2. That will be my D set, okay? And I won't play around with other D sets in my possible worlds here. So this sort of the domain of my worlds will be a constant domain. It will consist of the set 1, 2, 2 numbers, that's it. And now my worlds will be quintuples, 5 tuples of this form. You have the D set, the set 1, 2, and then I put in the 1 here and the 2, okay? So that's like mathematical structures where you have distinguished objects, as we sometimes have, right? Say you want to do analysis, the calculus of real numbers, then you have the set of real numbers, and maybe the 0 is a distinguished object, okay? Here, 1 and 2, they're both distinguished objects. I plug them into my world. And then I have two sets, which are binary relations on D. So M is a binary relation, a set of pairs in D, and C is a binary relation on D, a set of pairs in D. And the only thing that I assume is that C is a congruence relation, okay? So it's reflexive, symmetric, transitive, has some structural properties. It's an equivalence relation. And in fact, it's a congruence relation. And that roughly means that for all structural purposes, a world thinks of C as something like an identity relation for that world, okay? So this means, for example, if C thinks that 1 is identical to 2, that is, 1 stands in the C relation to 2, 1 and 2 are indistinguishable from the viewpoint of that world. For example, if 1 stands in the M relation to 1, and 1 is congruent C to 2, then 1 must also stand in the M relation to 2, and 2 to 1, and 2 to 2, because 1, 2 are indistinguishable once 1 and 2 are congruent. Okay, so congruence is something like the identity that is built into my possible worlds. And now, again, given these desiderata, I run through all the combinatorial possibilities. Okay, and now the final new bit is that I add another component, which I'll call, let's pick a term, an accessibility relation. Well, I was already telling you, I'm now interested in a necessity operator. So you were figuring probably has an accessibility relation, and I have. Again, I'm doing intentional semantics in a sense, okay? And now here I actually explicitly define the accessibility relation. I say W prime, a world, is accessible from W, just in case their congruence relations are identical. The congruence relation C of the one world is identical to the congruence relation C prime of the other world. So very simple case, okay? For the more interesting cases, you would have to refine that. Okay, and now the only thing that I still owe you is the labeling structure. And now the labeling consists of following. So we have a domain that we want to reason or talk about. And in this case, it's a set with members MS and ES, okay? And again, you know, sometimes you're required to have some examples. So what could MS be? I tell you here, MS is the last body to be seen in the sky before sunrise in the period between the beginning of the year to mid-March. Well, it's the morning star. Okay, and ES is the first body to be seen in the sky after sunset in the period between mid-August to the end of the year. So what's ES? It's the evening star. And you take them and put them into that set, and that's my domain. Now, in fact, since we are all educated, okay, we know that actually MS and ES are identical. It's just Venus, okay? The way I've written things here is I didn't want to presuppose that. So say we're at some point of time where astronomers were not clear about that, okay? They might still have done everything that I'm currently about to do with my little framework. So it's not that my framework is presupposing already some astronomical knowledge about MS being identical to ES. That's why I write things up in this way. But really, the domain of the labeling structure is a singleton set. It just includes one member, okay? But it doesn't matter. Then I put MS here and ES, so I put Venus here 2 times. And then I put the movement pattern of morning star and evening star here as a binary relation. So move pattern, okay, is a binary relation, a set of ordered pairs D and D prime of objects in my domain, MS and ES. The movement patterns of D and D prime is such that, you know, they periodically sort of switch places, as it were, okay? There's a stage of appearance of D in the morning sky without an appearance of D prime in the evening sky, followed by a stage of appearance of D prime in the evening sky without an appearance of D in the morning sky, and so on, okay, periodically, with breaks in between the stages and always observed from Earth, okay? So really it's, you know, Venus occurring in the morning without Venus occurring in the evening, and then it's the other way around and so on, okay? So obviously Venus stands in that movement pattern to itself, okay? And that's the movement pattern that is my 4th component here. And then ID, that's the identity relation, okay? So morning star identical to evening star. So it's a full identity, okay? It's just the set of one pair, namely Venus, Venus, and that's the thing here, okay? And then I add an asterisk here. And again, that's a little mnemotechnical device that reminds you that the final component that I had, the R thing, again, a purely mathematical relation, okay? The R component will not be labeled. There is no label that compares, that I need to compare the R relation with when I define actuality and truth. That's the important point here, okay? So now take all of that together, W, the accessibility relation, and label, you get conceptual framework. That's my 3rd example framework, okay? Now you might think, hey, you're cheating, now you have this R, but R is still purely mathematical. So there's still this purely mathematical part, and then there's the labeling, and that's the thing that I promised. And now I define actuality in the way, I say W is actual in the framework just in case there's a labeling function, same thing as before, But now I make sure that that object is mapped to MS, 2 is mapped to ES, okay? And then the M component is mapped to the movement pattern, and the C relation is mapped to the identity relation, okay? So there is no R here. As promised, the accessibility relation does not figure ultimately in the definition of actuality, and therefore also not in the truth condition of propositions, okay? And since I run through all the combinatorial possibilities here, I do not impose any constraint on the label structure, right? Again, there's a little proviso. So I assume that the C relation is a congruence relation, okay? So, and this is a little bit of cheating because it's somehow I already know that I want to map the C relation to the identity relation. And we know that the identity relation structurally is a congruence relation, okay? But think of it in a way that that's also something that we like to presuppose in first order logic with identity, okay? So therefore, I'm not too worried about it. If you're worried, we can talk about it later in the Q&A, okay? So again, I want to say, by math alone and the way I define the framework, there must be an actual world in the framework, okay? So the framework does not presuppose that evening star is identical to morning star, okay? I run through the possibilities here, okay? In one world, 1 is not congruent to 2. In another, they are congruent, okay? And then I run through the possibilities with respect to the movement pattern, okay? The only thing is the movement pattern has to respect the congruence relation, which I then map to identity. But that's all that I build into it, okay? That's all. It could be just one entity. It could be 2 entities. It could have a cool movement pattern. It could not have a cool movement pattern, okay? But whatever the morning star and the evening star out there are like, I must be able to capture their structure by one of my worlds in the framework because I've run through all the possibilities. Same idea as before. It follows here that there is exactly one world that is actual, and that's not a big surprise. This is this one thing here. Venus equals morning star equals evening star. So Venus does stand in the movement pattern with respect to itself, okay? And you get the full congruence relation. 1 and 2 are both mapped to Venus, and you get the full C relation. So now we can do the same thing as before. Look at propositions. So for example, collect all the worlds that include the pair 1, 2 in their movement pattern. So roughly that's the proposition that in ordinary language we would express by the sentence, the morning star and the evening star instantiate this periodic movement pattern. Okay, because they stand in the movement pattern relation with respect to each other. Okay, you collect all the worlds in which they stand in the movement pattern and you exclude the worlds in which they do not. Okay, that's the proposition A. Or here's another proposition B. You collect all the worlds where you have all the pairs from 1, 1 to 2, 2 in the congruence relation. So in colloquial English, we would say the morning star is identical to the evening star, and that's the proposition that is expressed by that. Okay, it's an identity proposition, as it were. And now you can necessitate that. Let's call that proposition NB. That's the set of all worlds W, such that at all W prime accessible from them, okay, here we have the R relation, B, that proposition here, morning star identical to evening star, is true at this accessible world in the framework, okay? So that proposition NB, we would normally express by it is necessary that the morning star is identical to the evening star, okay? And the R relation has a role here to play. It helps us to determine that proposition, okay? And now, once we have these 3 sets, we can check are they true or not. And in fact, they are true because they include W1 as a member. That's easy to check, right? So for example, W1 is a member of A because set A was the set of worlds that include 1 and 2 in their movement pattern, okay? And in fact, that's the case here. The pair 1, 2 is in the movement pattern here. And in fact, all of these sets are true. And their truth is due to the framework and the facts, as it were. Why? Because these propositions can easily be seen to be proper subsets of the set of all worlds. They are not identical to the set of all worlds whatsoever. They rule something out, okay? In contrast, if I had a look at this proposition here, the complement of B, okay? Oh, sorry. The complement of B, union NB, okay? That is also a true proposition, but in fact, it's identical to the set of all worlds whatsoever in the framework, okay? And we already said there must be an actual world in the set of all worlds in the framework by math alone and the definition of the framework, okay? So that proposition is true in virtue of, math and the framework, not in virtue of the facts, okay? Now, what's this weird proposition here? Well, think of it as a material conditional. It's something like not B or necessity of B, okay? Or think of it in if B, then necessity of B, okay? So this might ring a Kripkean bell, I will drive home that point now. Add a language again. First to the language, say we have individual constants for the morning star and the evening star, predicates for the movement pattern and for identity, and a necessity operator, a sentential necessity operator, as in standard possible world semantics. And then you can make now more precise what I said before, that in colloquial English, certain sentences would express propositions. We now have logical counterparts of these colloquial sentences in the object language. Okay, they look like this. And they express the propositions that I, were referring to on my previous slide. And these sentences are therefore true in the framework, okay, because they're propositions. The propositions expressed by them are true, but they are not analytic in the framework because they rule out certain candidates in our possible worlds. Okay, they're not, the propositions they express is not the same as the set of all possible worlds. This is in contrast with the sentence, if A equals B, then it is necessary that A equals B, which expresses that other set of possible worlds that I had before, namely the set of all worlds. That sentence is not just true in the framework, it's also analytic in the framework. Okay, and now you recognize this kind of Kripkean law here, and it becomes an analytic statement in that framework. So the upshot is, we could introduce a concept N again for necessity. It doesn't represent here. Okay, and the operator box that I use here ends up being a merely expressive device. It expresses a concept, but it doesn't represent a property out there. Okay, for exactly the same reasons as before. Okay, and again, you might think that's odd, but no, actually you don't think, because you can see sort of the nice Kripkean outcome which you like to have. Okay, now I guess at this point you might say, yeah, finally, we can see what's going on. Hannes is reducing necessity to analyticity again. The old mistake that the logical empiricists made, and maybe I should switch off, now and do something more sensible. But that's not the case. That's not the case at all. Okay, and that's not my ambition either. Okay, so the box operator here in my object language does not express analyticity. So for example, box A equals B is true in the framework. Okay, it is necessary that morning star equals evening star is true in the framework. Yeah, this necessity claim is true in the framework. But remember, A equals B, morning star equals evening star is not analytic. Okay, so the truth of that necessity statement, right? You don't get that because the thing that's necessitated, A equals B, is analytic. It's not. Okay, so it's as it were a matter of the fact which world is actual. And then from the viewpoint of the actual world, you look at the worlds that are accessible. Okay, and then finally you get that box A equals B is true in the framework because it's true at the actual world, right? But what counts as actual, that involves the facts. Okay, so it's not about analyticity here. The Kripkean law, if A equals B, then it's necessary that A equals B. Okay, that's true at all worlds in the framework, and it's analytic. Okay, but box A equals B is not, and A equals B is not analytic either. Okay, I could even, wrap up the Kripkean thought if I added now subjective probabilities for degrees of belief. You can also derive that the astronomers believe in the necessity of the identity of the morning star and equal star of evening star is a posteriori rather than a priori. Okay, so you get a claim, you get a necessity that's not analytic, and it's a posteriori. You can get all of that in that framework. Okay, if you're interested to see how that goes, ask me later. I can show you in the Q&A, but I don't do that here. Okay, so you can reconstruct all the Kripkean verdicts. Okay, that's my point here in naming a necessity. Now, the same idea you can apply more broadly for other cases. So take something else, good old-fashioned instrumentalism about theoretical terms in science. Okay, so I'm not saying you have to be an instrumentalist. I'm just giving you a way of making instrumentalism about theoretical terms in science precise. Okay, say you thought that in Newtonian mechanics, the capital F symbol for force, okay, that's a theoretical term. And its only job really was to give you a way of expressing something interesting about, positions and time and velocity and stuff like that. And maybe similarly for mass, okay? So F and M, okay, force and mass, say they are theoretical terms, but they only neatly help you to express propositions, okay? But that's all there is to them. You can make that precise, and I've done that in another example that I'm not giving here, okay? You can reconstruct force, the force term and the mass term in Newtonian mechanics as merely expressive devices, okay? And thereby formally make more precise the idea that you can be an instrumentalist about these theoretical terms. Okay, if you're not an instrumentalist, okay, you label sort of the force components and the mass components as worlds with phenomena out there. That's also fine. And then the corresponding terms in your scientific object language will not end up being merely expressive devices, but will be like, you know, the predicate male or man that I had before. Okay. But in the same way as with the necessity operator, I can now give you a way of making more precise what it means that if you're an instrumentalist about theoretical terms, you want to say that theoretical terms only help us to express propositions, but these terms don't represent properties out there in the world. It's the same idea. Okay, so let me conclude. I've constructed 3 frameworks for merely expressive devices. And I want to say that these frameworks are all rational reconstructions of existing patterns of thought and language, and sort of successful reconstructions, okay? In the sense that their properties, the properties of these frameworks, are reasonably similar to thought and language prior to reconstruction, okay? So what I end up having in my framework is sufficiently similar to what I wanted to rationally reconstruct or explicate, to use the Canepian terms, okay? Using the framework, I hope you've seen, clarifies and precisifies and systematizes pre-theoretic thought and language. And that's exactly what Carnap does when he uses linguistic frameworks. So that's his term, okay? So my conceptual frameworks are really updated versions of Carnapian linguistic frameworks. For him, they were just tools in projects of rational reconstruction and explication. In each framework, the total underlying set of worlds is a mathematical construction and true by math alone. For the same reason, no empirical evidence is required to support its truth. So think of it in the following way. Some sentences and some propositions, you know, in principle, there could be 2 sources of justification, yeah, why you believe in them. One is, as it were, epistemic, it's to do with truth, and the other one is pragmatic. Okay, it's to do with sort of it being useful. Now, for theories, both of them have a job to play, a role to play, but for the set of all worlds in one of my frameworks, the first thing cancels out, okay, because you get the truth of the corresponding propositions, the set of all worlds, by math alone and the way I set up the framework. So you don't need any epistemic justification. That is gone. And the only thing that remains is pragmatic justification. And that is how I interpret Carnap when he says in Empiricism, Semantics, and Ontology that framework choice is purely pragmatic. Okay, theory choice is not. Framework choice is. Now, in each of my framework, the merely expressive devices are useful things. They're practically useful. I don't want to eliminate them at all. Yeah, they can be useful in 2 ways. They might enable us to express propositions that we couldn't express otherwise. Okay, so we wouldn't even be able to grasp the thought, but with their help we can. Or we might have been able to grasp the thought in different ways, but in just in more complicated ways. So they help us to grasp the thought in a simpler way. That's the pragmatic thing again. Okay, and in either of these 2 ways, they can be really, really useful. In the first example, okay, the classic logical operators like disjunction, they end up being merely expressive devices. Yeah, as I said, they are purely structural. They don't reach into the empirical world. Okay, they don't pick out anything in the real world. They are stuck in math, and that's their job. They do not represent a property out there. And in fact, one can show that there are lots of such frameworks available. Right, one is sort of one with a classical or, and another one might be one with an intuitionistic or, an intuitionistic negation. And there might be other logical frameworks. And in fact, I've reconstructed them. Yeah, you get the idea how that might work. What happens then is that these logical symbols for these other logical frameworks, they contribute again to propositions, but they contribute differently than the classical logical symbols. But they still end up being merely expressive devices. They do not reach into the world either, okay, in the standard reconstructions that I hope you get enough of an idea of how that might work, okay? But there are many such frameworks and there's a kind of tolerance about them, but still one might be pragmatically way more useful than another for certain purposes, yeah? Therefore, when choosing logical systems is likened to inference to the best explanations, as some people have done, some of them in the audience, I think there's something right and something wrong about that, okay? With respect to the pragmatic aspects, yeah, of choosing theories, that's right. That's exactly how I think of it that's exactly the way I suggest to think of it, okay? But if you thought that choosing logical systems is sort of exactly like theory choice, okay? There's a phenomenon out there that the logical symbols need to track, sort of, okay? And then, you know, the phenomenon out there is maybe an empirical one or something like that, then this would go too far. This is nothing that you need in the frameworks in the way that I've constructed, because the logical symbols are merely expressive devices. In the other example, you get, I think, a notion of truth in virtue of meaning, but without, you know, metaphysical connotations. It's nothing that's made true in a truth maker or grounding sense or anything like that. Okay, it's a semantic notion of analyticity that you get. And it's if that sentence here in framework F prime is analytic, that doesn't sort of reflect anything intrinsic about that sentence, but really it reflects how information, how a body of information is organized in the framework, hopefully efficiently for a certain purpose. Okay, that's all. That's why one and the same sentence can be analytic in one framework, but synthetic, not analytic in another framework, because then the framework is defined, is set up differently. Okay, so this is like you open up your math textbook. Okay, some define continuous function in a certain way, and then a certain statement ends up being analytic. Another textbook would define the notion of continuous function a different way. And you know, what is analytic in the one textbook might not be analytic in the other textbook. Okay, and in both textbooks they might be useful. Okay, maybe one is more useful than another, and you know, mathematicians change around their definitions all the time for certain purposes, and that's how I want you to think of my analytic statements in a framework like the second one. Okay, and that's all the business concerning analyticity that I'm involved in. Okay, so Quine, I think, was right that there is no clear notion of analyticity for natural language, except maybe, you know, think of Boghossian, maybe a epistemic notion or so. That's, I will not deal with that here. Okay, but it's certainly not what Carnap was interested in. Carnap was interested in a notion of analyticity that comes with artificially constructed linguistic frameworks. Okay, that's exactly what I've done here. Okay, and these frameworks for Carnap didn't have factual import, and they do not have factual import in my case. Yeah. And apart from that, I hope you've seen that my definition of analyticity is perfectly clear and precise, and actually quite ordinary and traditional, and there's no funny business going on, I want to say. Okay, so I hope this addresses some of the worries that people might have had about analyticity. Other people have other ways of addressing that. Some of them are in the audience again, but you know, I will bracket that. And then finally, with respect to metaphysical necessity, I hope you've seen that this is a way of rationally reconstructing Kripke's claim that morning star equals evening star is necessary, synthetic, and even a posteriori. Okay, and all of that is compatible with the box operator being framework relative and not representing a property out there. Okay, so you can be Kripkean and still buy into Carnapian framework building. And as far as I can see, you can reconstruct all the other Kripkean examples of necessary a posteriori claims. Okay, C is the daughter of D, water is H2O, tigers are mammals. Okay, you would preserve them from one world to the next across the accessibility relation, similar idea. Okay, and you get the corresponding statements to be necessary. I want to say metaphysically necessary, but not analytic. Okay, and this gives you then the idea maybe all the central terms and operators of metaphysics can be reconstructed in similar ways as merely expressive devices. Okay, and then you have a new idea maybe what metaphysics could be, the role that it could play in philosophy. It could be reconstructed as that part of philosophy that constructs or reconstructs conceptual frameworks, and then recommends you to speak from within these frameworks for certain purposes. Okay. Now, I've done the same thing for other things. So Tim, for example, is interested in counterfactuals, more interested in some sense than in metaphysical necessity. And you can do the same thing for the counterfactual if then, and it becomes a merely expressive device. Or objective chance function symbols, normative operators. Okay, so that's something interesting maybe for meta-ethics and so on. Okay. Maybe ultimately you even get a version of logicism going. Maybe mathematical symbols are themselves just merely expressive devices. They help you to grasp thoughts about the world out there, but they don't contribute to the truth conditions of the propositions thereby expressed about the world out there. Okay, but you know, these things I haven't touched, and I'm not totally clear about all these things myself at this point. So ultimately, I hope some of the tenets of Carnapian logical empiricism can be vindicated, at least to the extent to which they were dealing with merely expressive devices. Gracias. Muchas gracias.